Math 2. This is Unit 6, Lesson 14 practice, and we are on page 108 of your workbook. And Lesson 14 is about using coordinates to prove geometric theorems. So we want to prove things geometrically using coordinates. So let's take a look at number 1. Number 1 says a quadrilateral. Remember, a quadrilateral has 4 sides, has vertices A, B, C, and D. Prove that A, B, C, D is a parallelogram. So we're being asked to prove that this quadrilateral is parallelogram. So let's try graphing it and taking a look at it. So A is at 0, 0. And then B is at 1, 3. Let's pencil in C, that's at 0, 4. And D is at negative 1, 1. So if I connect those, this is a rough sketch, but this is a sketch of my quadrilateral. And it wants me to prove that it's a parallelogram. So I have to remember what it means to be a parallelogram. To be a parallelogram, it means that opposite sides are parallel. And we can show that. So I have to remember what it means to be parallel. To be parallel, lines must have the same slope. So to do this problem, I'm going to show opposite sides have the same slope. So I'd like to show that the slope of DC and the slope of AB are the same because DC and AB are opposite of each other. So let's get started. I have to remember my slope formula. My slope formula that is on your formula sheet, but we've used throughout this unit, is that slope equals the difference in my y values over the difference in my x's. And if you're wondering why I don't use slope triangles, primarily it's because this is a sketch. My drawing is not very good. So I don't want to use slope triangles because of that. The other reason is I want to practice using the formula for slope. I want you to see it again. You've got to be able to do it for Thursday and Friday's quiz and for your review worksheet that's due Wednesday. So it's good to practice slope. So the slope of DC. So I need to find my 2 coordinates. That is my 0, 4 and my negative 1, 1. And I'm going to subtract my y values. It doesn't matter which one you use first. I'm going to use the 1 minus 4. But since I use the 1 first in the denominator, I need to use in the numerator. I need to use the negative 1 for x first in the denominator. So it's negative 1 minus 0. So I get on top 1 minus 4 is negative 3 over negative 1 minus 0, which is negative 1. And a negative over a negative is a positive. So it looks like the slope of DC is 3. So let's see what the slope of AB is. So again, I use my slope formula. That's the difference in my y values. So let's go find A and B. A is 0, 0, and B is 1, 3. So I'm going to use the 3 first. So that'll be my first y. So 3 minus 0 all over 1 minus 0. And that would be 3 over 1 or 3. So it looks to me like the slope of DC and the slope of AB are the same. So that's a great start, but I'm not done. Both pairs of opposite sides have to be parallel. So let's go see if the slope, so now let's do my 2 little opposite sides. I'm trying to find the slope of BC or CB. It doesn't matter which way you say it. is equal to the slope of AD or DA. It doesn't matter which way. So I want to go find those slopes next. So again, I'm doing my y value over my x values. So when I look at BC, it is 1, 3, and 0, 4. I could use the 4 or the 3. I'm going to use the 4 first, but you could have used either. Since I used the 4 first, then in the denominator I have to use the 0 first because the 4 goes with the x coordinate of 0. So 0 minus 1. This is 1 over negative 1. Okay, out to the side, 1 over negative 1 is the same thing as negative 1 over 1, and it's the same thing as a negative out in front of 1 over 1, which is just negative 1. So if it's okay with you guys, I'm just going to call that negative 1. So the slope of BC is negative 1. Let's go find the slope of AD. Let's see if it's also negative 1. So AD, D is negative 1, 1, and A is 0, 0. So again, I have to use my y values. So I'm either going to use a 1 or a 0. It doesn't really matter which one you use first. I'm going to use 1 minus 0. But since I used the 1 first, then I have to use the negative 1 for my first x. And again, I get positive 1 over negative 1, and I know that that's negative 1. So I've shown that opposite sides are parallel over here on the left by showing that they have the same slope. So I can say that A, B, C, D is a parallelogram because opposite sides have the same slope. And that's how I used geometry to prove a theorem. I used coordinates to prove a geometric theorem about a parallelogram. So let's take a look at number 2. So number 2 says that a rhombus has vertices 0, 0, 5, 0, 3, 4, and 8, 4. It wants me to find the slopes of the diagonals. Okay. And what do the slopes tell me about the diagonals? Well, let's go check this out. So I'm going to sketch this. My vertices are at 0, 0. I'm not sure. They don't say what to call that. I'm going to call it A. And at 5, 0, 1, 2, 3, 4, 5. We'll call that B. That's 5, 0. 3, 4, 1, 2, 3, 1, 2, 3, 4. We'll call that 3, 4, and 8, 4. So 5, 6, 7, 8, and then up here, this is 8, 4. And I'll call this C, and I'll call this D. And now I'm going to join those points. And it's telling me they're a rhombus. Just to remind you, a rhombus, similar to a square, has 4 equal sides, but it's slanted. So unlike a square, it does not have right angles. So this is actually asking me about the diagonals of the rhombus. So let's draw those in. Let's connect my A and my C. That's one of my diagonals. And let's connect my B and my D. That's the other diagonal. It says to find the slopes of those two diagonals. So because I need more room, I'm actually going to write A in this area down here. So I need to find the slope of the diagonals. So I need to find the slope of BD. That's one of my diagonals. I also need to find then the slope of AC. That's my other diagonal. So just like up above, I'm going to use the slope formula. So my slope formula is the difference in my y values over the difference in my x values. So let's go find BD. That is 3, 4, and 5, 0. So I can start by using the 4 or using the 0. It doesn't really matter. I'm going to use the 4 first. So 4 minus 0. Because I did that, for the x's, I have to use the 3 first. That's 3 minus 5. I get 4 over negative 2, and it's a positive divided by a negative, so I know my answer is negative, and it looks like it's going to be a negative 2. Okay, great. So now let's go find the slope of AC. Again, I need my coordinates, so let's go find AC. A is 0, 0, and my C is 8, 4. So it doesn't really matter if I start with the y that's 0 or the y that's 4. But once I pick one, so I'll pick the 4, so 4 minus 0, then I have to use the 8 first for the difference in the x's. So 8 minus 0. So I'm getting 4 over 8, which reduces to 1 over 2. So now I'm looking at the two slopes. They're not equal, not at all. One is negative 2, and the other one's a positive 1/2. If I go back to the negative 2 and I write it over 1, now when you're looking at the negative 2 over 1 and the positive 1/2, let's compare them. What are you guys noticing about those two slopes? They're not the same, but do you remember that they are opposite reciprocals? So the slope of BD, which is positive 2, and the slope of AC, which is, the slope of BD is negative 2, and the slope of AC is a positive 1/2, are opposite reciprocals. And what did that mean? Opposite reciprocals meant that our lines were perpendicular. So the diagonals are perpendicular. And that's answering the question for B. The red work is answering A, the slopes, and B, it says, what do the slopes tell you about the diagonals of a rhombus? So again, going back up to the top of my page, I use the coordinates to prove something geometric. I use the coordinates to prove that my diagonals of a rhombus were perpendicular. So let's take a look at 3A. It says, show that the triangle formed by the vertices 0, 0, 4, 3, and negative 2, 11 is a right triangle. Let's draw this before we even start thinking too much about it. So 0, 0, I'll call that A. And then 4, 3, 1, 2, 3, 4, 1, 2, 3. So this is my 4, 3. We'll call that B. Let's go back to A, that's my 0, 0. And then negative 2, 11. So over negative 2 and then up 11. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, way up here. So here is my negative 2, 11. Wow. Okay, so let's trace in my triangle. Okay. So I've drawn my triangle with those three coordinates. So going back up to the top of my page, remember I'm using coordinates to prove geometric theorems. Here I'm going to use coordinates to prove that I've got a right triangle. So let's figure out my right angle. I'm considering that B might be my right angle. So how can I use coordinates to prove B is a right angle? So I'm going to look at my segment AB, and this is the segment negative 2, 11 is that coordinate C. And I'm going to look at the segment BC. I think those two might be perpendicular. And if they're perpendicular, then that would make angle B a right angle. So now I'm trying to consider how to prove that. So I remember that perpendicular lines have opposite reciprocal slopes. So if I could show that these two lines that I made bold, AB and BC, have opposite reciprocal slopes, then I've shown that angle B is a right angle. Therefore, it's a right triangle. So I'd like to find, just like number 1, just like number 2, I'd like to find the slope of AB, and I'd like to find the slope of BC, and I'm going to compare them. So I'm going to use the slope formula again. I'm going to use my coordinates. So let's find the slope of AB. A is 0, 0, and B is 4, 3. It doesn't really matter if I start with a 3 or the 0. So let's start with 3. 3 minus 0 over the difference in my x's. That would be 4 minus 0. And so my slope is 3/4. Great. So now let's find the slope of BC. So the slope from B to C, I have the coordinates 4, 3, and negative 2, 11. So I either have to use the 3 or I have to use the 11. This is the numerator. It's a difference in my y's. Let's use the 11 first. So I have 11 minus 3. So now for the difference in my x's, I have to use the negative 2 first because he goes with the 11. Negative 2 minus 4. So 11 minus 3 gives me 8. And negative 2 minus 4, they're both negative, so I'm going to add and keep the sign. That makes them negative 6. I was at negative 2 on the number line. I took 4 more away. I'm at negative 6. Remember, it doesn't matter where the negative's at. Numerator, denominator, out in front. It's just negative. So I'm going to put it out in front. And then 8 over 6 reduces by 2 to 4 over 3. So looking at my two slopes, negative 4/3 and positive 3/4, my slopes are opposite reciprocals. Therefore then, I'm going to scratch out B for just a second so I can finish writing this. So since the slope of AB and BC are opposite reciprocals, then we know that they're perpendicular. Then we know what makes a right angle. So triangle ABC is a right triangle. Pretty cool, huh? So looking where you can check out this again, let's look at what we've done on this page. We've done slope over and over and over again. You were first introduced to slope formula in 7th and 8th grade, and we've used it off and on. We used it last year in Algebra 1 quite a bit, and then we used it off and on in this unit. The slope formula is a difference in the y values or the difference in the x's. I used it in number 1 to show that something was a parallelogram. I used it in number 2 to show that the diagonals were perpendicular. And finally, I used it in number 3 to show that a triangle is a right triangle. Again, going back to the top of my page, I used coordinates to prove geometric theorems, or I used coordinates to prove something geometric. So let's take a look at going back one page. This is page 107. Sorry, let me move through. So this is page 107 of your book. They are really doing what we just did, and it's written in the paragraphs. You're welcome to read through here, but I just want to talk for a moment about these. So this first one right here is a right triangle. So it discusses using the slope of, let me get my highlighter, using the slope of EF and the slope of FG to show that angle F is a right angle. That's exactly what you and I did on the previous page. So why don't you, if you want some extra practice, why don't you try this one? This is negative 7, 0 for E, G is 3, 5, and F is 1, 8. So find the slope of EF using your slope formula. Find the slope of FG using your slope formula, and you want them to be opposite reciprocals. Then you've proven that this is a right angle and that's a right triangle. Practice that. If you have any trouble, just bring it to our class, our Zoom class, and I'm happy to help you and take a look at it. So then let's take a look at the parallelogram. So this is a parallelogram, and you can prove that it's a parallelogram. Going back over here, this is like number 3 in the practice that we just did. It's a similar problem. And then this is like number 1 in the practice. you can prove that this is a parallelogram by showing opposite sides have the same slope. So let me grab my highlighter. You want to show, for instance, that DC and AB have the same slope. And you want to show, for instance, that AD and BC have the same slope. So you would need to go around and get your coordinates of all of them. So for example, C, it looks like your coordinate would be 11 and then 7. You need to go get all 4 of your coordinates, and then you can calculate your slopes. You're trying to show that CD and AB are the same, and that AD and BC are the same, just like in number 1 on the next page. So that gives you a second one to practice. You're welcome to read what it has listed below, but you could do the math to calculate the slopes. And if you run into any trouble, if your numbers aren't working out, come to Zoom and we'll talk about it. Don't forget to print your review sheet today and work on it a little bit each day so that it's ready to turn in Wednesday evening at 9. And don't forget to also bring your review sheet to our Zoom class so that we can do problems from it. Thank you.